So today we're on page 633 of your workbook, looking at solving systems of linear equations by elimination. So previously we've talked about solving systems of equations through graphing. Really helpful if you don't need an algebraic solution. And then if you do need an algebraic solution, then we're looking at either substitution as one option or elimination as a second option. So substitution becomes really helpful. We talked about the other day if you have a coefficient of one of your variables in one of the equations being either 1 or -1, meaning that it is very simple to isolate that variable and then be able to substitute in the expression to then solve your system of equations. The issue is if you don't have a coefficient of 1 or -1 for one of your variables, then you often end up with fractions, which is doable. However, it just becomes a little bit more difficult. So in order to avoid that, we can then use a process called elimination. So the whole goal, our method of elimination, our goal is to try to end up with coefficients that are the same or the opposite. My strong recommendation is that you are looking for coefficients, and you can see right here, coefficients for either x or y that are identical, perhaps except for the sign. So I'm actually going to say, rather than identical, I'm going to say that are opposites. Okay. So for example, here you can see positive 7y and -7y, so those are opposites then. And our goal then will be to add. Subtracting works if they are identical, meaning you have the same sign, but I will encourage you not to subtract simply because of the number of errors people make. Okay, so once we add the opposites, we're able to eliminate one of the variables. Then we end up with a single equation with one variable that we can solve and then substitute that value into the other equation in order to determine the value of our second variable. So let's take a look at class example number 1, and this will make a lot more sense. So I've got equations 1 and 2, and I'm just going to number those just to help us and talk through them as well. And so what we can see, as we pointed out earlier, is both equations 1 and 2 have that coefficient of y being the opposite. We have positive 7y and -7y. So we're set up perfectly to add equations 1 and 2. So notice how I've got my x's lined up, my y's lined up, as well as my constants lined up. So when we add them together, 2x and 3x make 5x, 7y and -7y is 0y's. I'm not even going to bother writing that down. And 13 and 2 make 15. So now we have a very simple equation. 5x equals 15. It's one equation, one unknown, that allows us quickly to solve for x. So 5x equals 15. We can then divide both sides by 5 and x equals 3. But of course we're not done because our solution again is a point of intersection, or it is the values for the variables that satisfy both equations. So we've got x, we now need y. So we'll take this x value and we're going to sub into, doesn't matter, either equation 1 or equation 2. So let's put it into 1. Both will work. So we'll have then 2 times 3 plus 7y is equal to 13, and then we'll just solve for y now. So we've got 6 plus 7y equals 13, and subtract 6 from each side. So 7y is equal to 7. Divide both sides by 7, and we quickly can see that y equals 1. So we have x equals 3 and y equals 1. And let's verify the solution satisfies both equations. So we've got two left side, right side verifications to do. So in 1, we've got the left side as 2x plus 7y, or 2 times 3 plus 7 times 1, so 6 plus 7, which is 13, and the right side of equation 1 is also 13, so left side equals right side. Awesome. And then in equation 2, we've got the left side being 3x minus 7y, or 3 times 3 minus 7 times 1, or 9 minus 7, which equals 2. And the right side of equation 2 is also 2, so left side equals right side. That means that our solution is 3 and 1, and so I can write that as, just to be clear then, I can write it using a solution set. We can practice our fancy set brackets, and we've got then either we can write it as an ordered pair being 3 and 1. I guess I didn't need that first set bracket to be quite as large, so that works. Or you could also separate them out and use the set brackets again and tell me that x equals 3 and y equals 1. So either way of showing your solution would be great. Okay, let's take a look at class example number 2. So in this particular case, when we look at equations 1 and 2, you can see the coefficients for the x's are exactly the same. So that lends itself to subtraction, which you can do. But again, I would really encourage you to, rather than subtract, to multiply one of the equations by -1 and then add the opposite. And the reason being is that oftentimes when we line up the equations, the very first thing that our brain wants to do is to add. So you may remember the first one, 2x minus 2x is 0x. By the time you get to the end, your brain is often adding. Never mind if you're having to subtract a negative, it becomes just that much more difficult. So again, I would urge you to multiply equation 2 by -1, which is simple as saying, hey, there's -2x minus 3y, negative 4.5, and now we're going to add those together. That is again 0x's, 6y and -3y make 3y, 6 and -4.5 is positive 1.5. One equation, one unknown will solve, so divide both sides by 3, so then y is equal to 0.5, or 1/2. Once we've found y, we need to determine x, so we will substitute that into either of the equations. It doesn't matter, 1 or 2, so let's put it into 1 then. So we'll substitute it into 1. So we would have 2x plus 6 times y, or 6 times 0.5, equal to 6, and solve. So 2x plus 3 equals 6. Subtract 3 from both sides. So then 2x is equal to 3, and then lastly, of course, divide both sides by 2, and x is equal to 3/2, or 1.5. Normally, I would probably just leave it as a fraction, but since y is equal to 0.5 as a decimal, then I just want to be consistent, so we'll write that as 1.5. So again, once we have a solution, we want to just verify that it satisfies both equations. Satisfies, again, means that we substitute our x and y values in, and the equations are true. So in 1, the left side is 2x plus 6y, or 2 times 1.5 plus 6 times 0.5. So 2 times 1.5 is 3, plus 6 times 0.5, which is 3 again, and that is 6. And the right side is also 6, so that's all good. Left side equals right side. In the second equation, we have the left side being, and I'm going to use the original, so not me multiplying by -1, but the original equation was 2x plus 3y, or 2 times 1.5 plus 3 times 0.5, or 3 plus 1.5, which is 4.5. And our right side, conveniently, is also 4.5, so left side equals right side for both values in both equations, which then confirms my solution that x is equal to 1.5 and y is equal to 0.5. Fantastic. Okay. So let's take a look at class example number 3. Now we notice that in the equations, I do not have the same or opposite coefficients. So now you need to make a decision. You want to pick one of the variables, either x or y, that you are going to eliminate. But before you can eliminate, you have to make sure that you have the same or, as I mentioned before, ideally the opposite coefficients. So I could eliminate the x's by multiplying equation 1 by -2, and then I would have -4x, which would be opposite to my 4x, so that's option 1. Or I could multiply equation 2 by 3, and that would give me the 12x and -3y, which is opposite to the positive 3y, so then I can go ahead and add. So if you take a look, it says part A, does adding or subtracting the equations eliminate either of the variables? No, it does not, and therefore you have to multiply one of the equations or both first. Okay, so the easiest way, as I indicated, and they've got right here, multiply the second equation by 3. So if we say 3 times equation 2, gives us then 12x minus 3y equals 66. And then I'm going to write down equation 1. I can write it right underneath, which is 2x plus 3y is equal to 4. Now that we have these opposite but the same but opposite coefficients, then we're going to add them together, which gives us 14x. 0y, which I don't need to write, 14x is equal to 70. Then solve, divide both sides by 14. So then x equals 5. Then we want to figure out what our y value is. So we will substitute it into either equation 1 or 2. Doesn't actually matter. I'm going to say substitute it in 1. So then 2 times 5, which is our x, plus 3y equals 4, or 10 plus 3y equals 4. Solve by subtracting 10 from both sides. 3y is equal to -6. Divide both sides by 3, and y is equal to -2. So now we have our values for x and y, and let's verify by substituting and doing left side, right side checks for both equations. So in 1, we've got the left side being 2x plus 3y, or 2 times 5 plus 3 times -2. And that gives us 10 minus 6, which is 4. The right side is also 4, so left side equals right side. So that's a great start. A little happy face there. And then in our second equation, then our left side is 4x minus y, or 4 times 5 minus -2. because y is negative 2 and we're subtracting y, so minus negative 2. So that will give us 20 plus 2, also known as 22. And conveniently, our right side is 22. And so once again, left side equals right side. And we have our solution. So we'll put in our fancy set brackets, and we'll say that here that x equals 5 and y equals negative 2. Okay, so most cases you would be totally done at this point. It now suggests that, hey, let's try it the other way. So rather than taking equation 2 and multiplying it by 3, why don't we take equation 1 and multiply it by something instead to be able to eliminate the x's. So since equation 2 has 4x, then if I want the opposite of 4x, I want negative 4x, so I'll multiply equation 1 by negative 2. So if we take equation 1 and multiply it by negative 2, then instead we have negative 4x minus 6y is equal to negative 8. So that's my new equation 1, and then we'll write down our original equation 2, which is 4x minus y is equal to 22, and that's our equation 2, and we're going to add these together, and just as planned, our x's eliminate each other. Negative 4x and 4x is just 0, negative 6y and negative y make negative 7y, and that is equal to then positive 14. Divide both sides by negative 7, and y then is equal to negative 2. So you can see that we end up with the same y value, which is no surprise whatsoever, and we'll substitute it again. We can put it into either one. We can substitute it back into the original number 1. So then that was 2x plus 3y, or 2x plus 3 times negative 2, and that had to equal 4. So 2x minus 6 is equal to 4. Add 6 to both sides. 2x equals 10, and divide both sides by 2, so x is equal to 5. And again, we're seeing what we had up here again, so I'm not going to go through the verification because we've already verified those values. Okay, let's take a look at class example number 4. Just going to change colors. So if you take a notice right here, we've got 5a plus 3b equals 3, 3a minus 7b equals 81. So we don't have opposites, we don't have the same coefficients, and so we need to get the same or the opposite. So we have to decide, what are we going to do? Are we going to work with A? Or are we going to work with B? You can see in the book, they actually go through and do both. Let's just do one or the other. So both will totally work. Sometimes I'm into, you know what, let's try to keep the numbers smaller and therefore more manageable. So if we take a look at A would require being a common multiple of 5 and 3 would be 15, whereas for B, our common would be 21 as a coefficient. So doesn't actually matter too much. The advantage of the B's is that one is positive, one is negative. The advantage of the A's, the numbers are a little bit smaller, so doesn't actually matter. So let's do this. Let's work on eliminating A. Okay, so we're going to skip these two parts, and we're just going to work on eliminating A then. So we've got equation 1 and equation 2. I'm actually going to just rewrite them down here, so when I flip the screen up, I don't have to keep going up and down. So we've got 5A plus 3B equals 3. And then the second one is 3a minus 7b equals 81. That's my equation 2. So If I want 15a, so, and I also want one of them to be negative, so I will take equation 1 and I'm going to multiply equation 1 times it by, let's go this one by 3, so that gives me 15a plus 9b is equal to 9. For equation 2, I want negative 15a, so I'm going to multiply that by negative 5. So that would then give me negative 15a plus 35b equals, and 5 times 81, that's negative times positive. 5 times 80 is 400, and then 5 times 1 is a 5, so negative 405. So now I've got my opposite coefficients, and I'm just going to go ahead and add these together. So 15a and negative 15a is 0, 9b and 35b is 44b, and negative 405 plus 9 is negative 396. And then to solve, we need to divide both sides by 44, and b is equal to negative 9. So now that we have our value for b, we need to find a, so we will substitute it in either equations 1 or equation 2. So let's just put it into 1. So then we've got 5a plus 3b, so 3 times negative 9 equals 3, or 5a minus 27 equals 3. Add 27 to both sides, so then 5a equals 30. Divide both sides by 5, and a is equal to 6. Excellent. So let's do our verification then, and we want to substitute, do a left side, right side check for both of them. So in 1, left side is 5a plus 3b, or 5 times 6 plus 3 times negative 9, or 30 plus negative 27, which is positive 3. The right side is also 3, so that works. In 2, our left side is 3a minus 7b, or 3 times 6 minus 7 times negative 9. 18 plus 63 is 81. The right side is also 81, and so left side equals right side. So we have our solution, and I'll use my solution set, and we'll say a is equal to 6 and b is equal to negative 9. Excellent. Okay, so for class example number 5, it's again similar to class example number 4 in that we don't have a quick step that we need, that we can do in order to get equal and opposite. We need to multiply both equations, but you can see the only little piece right here is that they are arranged slightly differently. So I would encourage you just to rearrange them the same, perhaps putting the x's and y's on one side and the constant on the other side so that they appear the same. So just to start that then, we would here in this case add 13 to both sides. So then we have 4x plus 2y is equal to 13. And I'm going to call that my new number 1. And for the second one, we'll move the 5y onto the left side. So we'll subtract 5y from both sides. So it ends up being 3x minus 5y is equal to 26. And that's my new number 2. So at this point, you can either isolate, or sorry, you can either eliminate x or y once you end up with the same coefficient. So if you want to hit pause for a moment and I'll work through the solution, and you can work through the solution and then we can compare. Okay, so you can see that I decided to take our equation 1 and multiply it by 5. And so then if I multiply this whole thing by 5, I've got 20x plus 10y equals 65. Then I am looking for negative 10y in the second equation. So if I multiply everything by 2, I would get my negative 10y. So 2 times equation 2 is 6x minus 10y equals 52. Then I'm going to add those new equations together. So 26x equals 117, dividing both sides by 22. So x is 4.5. Substitute that into equation 1, and we ended up with then y equals negative 2.5. When I do my verification, I'm actually checking my original equations 1 and 2. So if I made any mistakes in any of the manipulations, hopefully my verification will catch that. And so remember that you want both left side equal to right side for both of them. Okay, and so it does work out for both, that left side equals right side, and so our solution is in fact 4.5 for x and negative 2.5 for y. Let's take a look at class example number 6. So definitely looks way more confusing. One, the equations are much more complex. We've got fractions involved, we've got way more little bits and pieces to it. So let's take the time and eliminate those fraction pieces. And so for equation 1, we'll call these equation 1 and 2. So equation 1, we know we don't like that divide by 3, so we're going to then multiply by 3. But remember, we need to multiply everything by 3. Okay. We then also want to multiply by 5 to get rid of this denominator of 5. So everything being multiplied by 3 and 5, and so I know some of you like to simply multiply by 15, and that's fine. So when we multiply by 3, remember, and by 5, remember those are over 1, and so 3 over 3 ends up being 1 over 1. The 5 over 5 end up being 1 over 1. So really, if I take the time to clean it up, because I don't want to make any mistakes, it's going to look like this. 5 times x minus 2 minus 3 times y plus 2 is equal to 2 times 15. So at this point, then I'm really paying attention to this negative as well, because that's where a lot of people make mistakes. They forget to distribute that negative. So now I'm going to distribute in the 5 and distribute in the negative 3. So we end up with 5x minus 10 minus 3y minus 6 is equal to 30. And we'll clean that up again. 5x minus 3y. And then let's here add 10 to both sides as well. We'll also add 6 to both sides. So adding 10 and 6 to the 30 will make that 5x minus 3y equals 46. So this is my new and improved number 1 equation. So I'm going to call this 1a. For number 2, we've got the denominators 5. We've also got denominator 2. So I'm going to take this and I'm going to multiply this whole thing by 5. Then we'll multiply this whole thing also by 5 and this guy by 5. Oh, now we've also spotted a denominator of 2. So we'll multiply everything by 2 as well. So multiplying by 2 and by 5. So with this, 5 over 5 is just 1. 5 over 5 is just 1. The 2 over the 2 is just 1. So let's again rewrite this to avoid any mistakes. So we've got 2 times 3 times x plus 1 minus 2 times 4 times y minus 3 is equal to 21 times 5. Now, if you're afraid of making a mistake with that, because that is it's a difficult, tricky thing to do, you can multiply in that 3/5 and the -4/5 if that makes you feel a little bit better, and that might help avoid some of the mistakes. So at this point, let's take our time with this. So we've got then 2 times 3x plus 3 minus 2 times 4y minus 12 is equal to 105. Now we'll distribute the 2 in, so 6x plus 6. Distribute the -2 in, so -8y plus 24 is equal to 105. So we now have 6x minus 8y, and this is plus 6 plus 24, which is plus 30. So if I subtract 30 from both sides, then I have 6x minus 8y is equal to 75. And so this is my new and improved equation 2 that I will call 2a. So we've just taken a lot of time, and all we've done, unfortunately, is just clean up those equations, but that's a big piece. So at this point, we're ready to solve our system of equations. Unfortunately, we don't have any coefficients that are the same or opposite or 1 or -1, and so we are only left with the option of making those coefficients the same. So pick a coefficient and then decide to multiply, and so that we can eliminate. So perhaps I'll take equation 1 and 2, and we'll make the x's 30 and -30. So I'll aim to eliminate the x's. So let's take 1a, and I'm going to multiply. I'll switch color here. So I'll multiply 1a by 6. So 6 times 1a. So that gives me then 30x minus 18y is equal to 276. Okay, and then I'm going to take 2a. I'm going to multiply this by -5. And again, if it helps you to write it outside so that you can see that a little bit better, you're welcome to do so. So if I have -5 times 2a, I'm going to actually write it underneath the 30x minus 8y, and that way I can have that already lined up and ready to go. So if I multiply that by -5, I've got -30x, and then plus 40y is equal to 5 times 75, so that's 375, negative 375. And then since we've got the opposite x values, we can go ahead and add our new equation. So 30x and -30x is 0. Negative 18y, plus 40y is positive 22y, and negative 375 and positive 276 is equal to 99. So we'll divide both sides by 22. Unfortunately, it doesn't divide nicely, but it does reduce. So we'll divide them both by 11. So y is then 9/2. Okay. So then now I'm still left to figure out what my x value is. So I'm going to substitute it into 2a to figure that out. So in 2a, we've got 6x minus 8 times 9/2 is equal to 75. So remembering that that's 8/1. So if I'm multiplying here, I've got 8. I could do 8 times 9, 72, divide by 2, or I could simplify beforehand and say 8/2 is the same as 4/1. So then we've got 6x minus 36 is equal to 75, adding 36 to both sides. Then says we've got 6x is equal to 111, and I just need a little bit more space here. So 6x is equal to 111. We'll divide both sides by 6, and 111 does not divide nicely by 6, but it does divide by 3, so we can reduce that fraction. So 3 into 111 goes 37 times, so x is then 37 halves. And we have our x and y values. Can we go back and check that in the original equations? Certainly we can, and or else you could also try graphing those and putting those in to then figure out what your solution is to check that. Okay? Please let me know if you have questions. This last question is definitely a very, very tricky one. And, oh, I should write my solution down. And that being that, let's write this one as an ordered pair since it's x and y. So 37 halves and 9 halves is our solution. Great.